The next step for us is going to be writing the functions that allow us to scan data into the matrix and display this data. So let's go back to the matrix.c. Here we go. We have the stub of our code. So now we have to think a little. How are we going to display, for example, the content of a matrix? If we were using a regular matrix static array declaration in C, we would have two nested loops. Okay. Well, why not keeping the same structure? So int I, j, let's use that as a starter. Counter control loop I equals 0, I lesser than mb rows, I plus plus. Inside this loop, another loop for j equal 0, j lesser than nb, whoops, typo galore here again, nb columns, j plus plus. What do I need to do? I need to display the element index I and j. So printf %d, and I'm going to put like, well, let's just like use tabulation actually, %d tabulation. And this is going to be where I have my problem. How do I fetch the element of index I and j from my matrix? Well, I have a formula to apply. I could use it right here. Another possibility is for me to use a little function called get element, okay, whatever you want to call it. Let's call it, for example, the matrix get, pass the coordinate, and let this function do the job. Okay, so the matrix get is going to tell us, is going to return to us the value of a given element of our matrix and apply the formula that I was given. This value is going to be printed by printf, and we are fine. Now, every time I'm done with a row, printf \n to go to the next line. All right. And when I'm done with the table, well, that's it. I'm done. So we have the display function here. It's going to be really easy to mimic our display function when we want to scan something. And I just realized that I might want to give to the matrix get the matrix itself so that it can fetch from that array the elemental coordinate I and j. That might help just a little. So now that I have this little more correct code, let's go here, and I'm going to do the same thing for scan. Okay, the difference here is that we don't want to do a scanf. Okay, this time we want to do a printf. We don't want to do a printf, we want to do a scanf. So I'm going to prompt the user for entering element, and I'm going to give the coordinate, okay, %d, %d. And then I'm going to wait for the user to enter something. I'm going to display I, j, as those coordinates, semicolon, and add curly brace here, curly brace there. Now what I have to do is to do a scanf. So I don't need to get the value of the matrix. I need to set the result of a scanf. Okay, so I'm going to have a variable tmp of type integer and do a scanf %d and %tmp. Once I'm done with that, I'm going to rely on a little function called the matrix set with data I, j, and a value which is going to be tmp. So whether or not you want to let access to our programmer to the matrix set and the matrix get function is irrelevant. What we are using them here is primarily for us. Okay. In a wider context, I would say that definitely these are the kind of function you want to implement for others as well to manipulate your matrix, okay? But here, the need stemmed from our own needs. So let's implement those functions real quick. Matrix get. What is it going to take? First, a pointer on the matrix itself. Int, I'm going to call it x, so the number of row, oh well, let's call it something more explicit. Int row, int column. And this is a get function, so it doesn't take anything more than that. And then, inside the get function, we are going to apply our formula. So everything is based on the address at which a matrix starts, data. Okay, if we have a look real quick at the specification of the work to do, we're going to take this address, add the number of row times the size of an entire row, plus the number of the index in the columns times the size of an int. So let's try this. Data. I'm going to have a pointer here, p equal data plus. So we are talking about row times the size of a row. How do I know the size of a row here? Well, I have a problem. So I'm going to write here size of row and come back to it in a couple of seconds. Plus column time the size of a single int. So we have here, what is our issue? Our issue is that when we are right here in the middle of the matrix get function, we don't know actually how many rows are there total. We just know the coordinates of the element we are trying to access. So we don't have enough information actually to figure this out, which means when I call it here, the easiest way for me to solve this problem is to pass here the number of rows. And this is really the number of rows and the number of columns. I could probably simplify by removing one of these. We're going to see in a second. These are really the size information about my matrix, followed by the coordinate of what I need to access. So int row size, why not? Int column, oops, yes, row size first and then int column size second. And I'm going to be able here to compute the size of a row. What is the size of a row? This is row size times size of an integer. Okay, so we have here a way to actually compute the address of the element. We're going to have to make sure that this is correct, and using the display matrix typically would help us achieve that. So we have now our pointer here to the correct address. What is the next step? Well, we try to get this value. So to get this value, I'm going to simply return star p, whatever is located at this address. I just use pointer arithmetic to locate myself, and then I return what is there. Well, let's try to do the same thing now for set, the matrix set function. Okay, int star data, int row size. I'm going to follow for now the same. And I really don't need the column size. Okay, actually, yes, I do need the column size. I just realized that I actually inverted my need here. Why do I need the column size? I need the column size because to establish the size of a row, it's the column size that is going to tell me how many integers there is on a single row. So I did a little whoopsie there. Okay, column size times size of. So I do need column size. It's row size that I've not been using so far. Int row, int column. Okay, and pretty much the situation is the same. I need to still compute what is the address in P, and then what do? And then I need to set my value, int value, to this address. So I would have something like int star P equals the same formula than above, and then star P equal value. So I'm using twice the formula here. Not necessarily something I want to do all the time. So I could isolate this in another function. The bottom line is that if I change the underlying representation of my two-dimensional matrix, I can simply rewrite this function instead of going through everything I went through right now. So I'm going to use int data, int star data, int row size, int column size, etc. So let me try something here. What if I just take this, compute here my coordinate, and return it? I return a pointer on the element of coordinates row column. And instead of having a get and set function, I could still have a get and set function and just call this function to get the coordinate and then modify the value. Instead of doing that, I could as well just access directly the element from matrix display and matrix scan. So which one is the best? Well, if you look only at matrix display and matrix scan, well, obviously I could do without matrix set, matrix get. The main thing that was bothering me is having this formula outside of any function. Okay, just in the wild, cut and pasted in two different functions. If you'll think a little larger, do you want the programmers that are going to use your mini library to be capable to get and set value arbitrarily in the middle? Probably. So, okay, let's rewrite this we're using now the matrix underscore coordinates. We have the data, the row size, column size, the row, and the column. This is going to be our get function, which I'm going to rewrite using the function above, the matrix coordinates. And I'm going to pass data, row size, column size, row, column with an N. Be better. So I get the pointer first, and then I assign a value. And guess what I'm going to do here? Same thing. I'm going to assign my pointer to the value of the address corresponding to the coordinate that I have here, row and column, and then I'm going to, instead of assigning a value, I'm confusing the two functions here, sorry about that, return star p when I want to get the value located at that address, and star p assign value when I want to just set a given value at that address. So I've been pretty much adding 3 different functions here. Okay, just because I felt the need for them to reorganize my code a little more cleanly. Because of those 3 functions, now the display is just a matter of repetitively calling the matrix get data, and I need to pass here number of row, number of column, and then my coordinate. And scanning is just a matter of setting the value to whatever I scan. And once again, here I need to pass NB rows. Let me double check that real quick. Where am I? Yes. NB rows is going to be the first one to be passed here, followed by NB columns, followed by the coordinate and my value, which is, in this case, TMP. Okay, let me have a look real quick here. Matrix display should return void. I was wondering what this was doing there. So I have my display and scan function calling matrix set matrix get function, themselves calling the matrix coordinate function. Let's save. Let's go to the header file and update actually our prototypes. So I'm going to include those functions for the reason I discussed while I was coding. I'm going to include those functions in the header file so that others can use them. Let's save. And I'm going to compile to make sure that this code is syntactically correct. So GCC, couple of problem, matrix.c line 52, implicit declaration of printf. Then you can see here implicit declaration of scanf. So let's try to get rid of that. This is going to be relatively easy. That just means that I need to include without the typo stdio.h. Enter. Save. Go back to Conqueror. Compile the code. Still a little typo here, line 66, syntax error before parentheses, closing parentheses. So let's go to line 66. And I have an extra parenthesis here. Save. Go to Conqueror. Wrong window. There we go again. Compile. We're good. If I run it right now, not much is going to happen because in my test, I'm just testing dynamical aspects. Now I need to test also, what do I have? I'm going to call it test interactive. I need to test how to read from the keyboard. I need to test how to display. So clearly here, I'm not going to be able to automate the test as I would like to, okay? Because I'm dealing with interactive function like display and scan. So nonetheless, let's go here, void test interactive, opening curly brace. And what am I going to do with that? Well, I need int star p, which I'm going to assign to the result of allocating, let's say, I've been using a 2x3 matrix so far. Let's keep with that, okay? 2x3. And then I'm going to request data from the user to fill it. So this is going to be done by the matrix scan. And then I'm going to pass p, size, 2x3. And let me double check. I think this is all we need. The matrix scan, yes, that's it. And then I'm going to call the display option with the same parameter. So this is going to allow me to pretty much make sure that I can read value for this matrix, I can redisplay them and they are the same. And by checking this visually, I'm going to be able actually to check if the get and set function are working. And I'm going to be able to check by extension whether the coordinates function is also working. So before to get carried over, let's compile. Let's run. Element 0, 0, well, let's call it 0, then 1, then 2. I filled my first row. Then I go 3, 4, 5, 0, 1, 2, 3, 4, 5. So we have actually code that is functional here, and I'm going to put back on the screen the code that we just developed.